I call this project EC2 Console. In the end, what I am talking about is about setting up a virtual machine in Amazon Web Services, in this case an EC2 instance. That EC2 instance could have different sizes. Of course, they can be defined in the CloudFormation configuration file. Here you have some suggestions. By default, we use a T3A X large, which has 4 virtual CPUs and 16 gigs of RAM. Take care, because the cost, it is 15 cents per hour. It's not a lot, and it could be extremely useful when you deploy that for doing something concrete. But if you have to have that running 24/7 for a long time, maybe it could be such amount of money. The CloudFormation is defined here. Here you have the parameters for calling it. By default, this instance will be launched in the region EU West 1, as you can read here. Of course, just modifying the CloudFormation, you could launch that in another place. And obviously, you will need to have proper credentials for running that stuff. Once this is set, what you will get when you deploy all the stuff will be a remote instance with a virtual machine in the end, with Ubuntu 24.04. And in that machine, you will have tools like AWS command line interface version 2, Docker Compose, and Docker, the community edition, and also the Docker Compose, everything ready to be used from the Ubuntu user, UV as a Python package manager, Micromamba, also ready to be used. And then you'll have a window environment based on Window Manager XFCE 4, and that virtual environment, Windows virtual environment, not Windows, take care, will be accessed thanks to Chrome Remote Desktop, which is optimal for running that in remote and not having to redirect ports in the server, neither in the client. So very, very good performance. Then you'll have also the terminal kitty installed in that window environment. Oh-my-posh for having a better experience when you use terminal. Zellij for managing sessions in your terminal if you want to use it. Also Nerd Fonts already installed for supporting UTF-8 emojis and other stuff in the command line, and Chromium as the default browser. Also Chrome is there. Also Google Chrome available. Okay, so both of them are ready to be used with a framework that you prefer. And then inside that remote instance, on the home of the user Ubuntu, you'll have a sample project or 2 sample projects, both of them equal, just a hello world created on JupyterLab. But one JupyterLab, it will be deployed using UV, and another JupyterLab will be deployed using Micromamba. Okay, then the first web interface will be at this port, and the other web interface in the other port. Security group will be adapted for letting you access to both ports. Okay, and then of course, just with a remote browser, you can access there, or with a local browser, the ones that we already said here, could access locally to both 2 ports. Not only that, you also have, it is not here, I see. Okay, anyway, you will have Visual Studio Code installed for running locally. Okay, so in that virtual environment, you can use Visual Studio Code and install the extensions that you want. By default, you have some of them. And with those extensions, you can run also Jupyter inside or through the UV environment and through the Micromamba environment. Later in this video, I will demonstrate how all those things work. And this is just the introduction. Then in the deployment process, the first thing that you have to do, once you have the project cloned, like I have here, the first thing to do is execute this command for creating the EC2 key. As you see, I don't have EC2 key here. Then just copy and pasting that. Oh, now I don't have credentials. Let me get my credentials as a user. I will copy those credentials. Copy them here. And then executing the command that I said before. Now we have created this EC2 instance key. As you can see here, it is the private key. Perfect. Then first step done. Second step will be create the stack. So if I copy this command, okay, solved the issue. Now let me launch the stack. It is the stack ID that it has been created. If I go back to my AWS console for checking the CloudFormation stack, we have CloudFormation. Yes, I have to change the region. Like it is EC2 Console now already created. Okay, so that instance and the security group related on that is properly deployed. So if I copy this command, of course it will instantly exit because we don't have to wait anything because it has been already created. And with that, we will get the IP address, okay, of the instance that we have been deployed. Then for connecting to that instance, I think it will be in the documentation at some point. Yeah, here it is. Okay, we can use SSH minus EC2 Ubuntu user and that IP address that we already copied. So now here I am inside this EC2 instance. Okay, then that's good. If I want to deploy, okay, I will open a new terminal. Okay, it is new terminal. I will change the name of this terminal that saying this is EC2. Okay, and this is local. Then once we are here, we have this interesting command, all installs Docker and desktop environment. That's good. Okay. I will use that just for testing, and later I will deploy the rest of the stacks. Here I put the IP address that I copied before. Okay. Then we are provisioning the Docker. Okay. In theory, Docker is not there. You see, Docker is not installed. And when this is installed, Docker will be available. And then the same thing with the desktop. Okay, in the end desktop, it is a window manager, so a graphic console for launching Linux applications. And thanks to the, let me say the Chrome, thanks to Chrome Remote Desktop, we'll have the chance to access to that, let me say, visual interface for managing Linux like if it is a local system. Okay. See, Docker is in the process of being installed. As I see here, for a while it is installed, I will check here all the available tags that you can select for deploying. Okay, have base, AWS. Okay, in the end we will install all of them. Okay, I just filtered to 2 of them, as you see, Docker and desktop, just for checking. By the way, in the end I want all of them, so you don't have to hesitate on running that without parameters. I hope this finishes fast. I will pause the video for not being so long without bringing value. As you can see here, those 2 tags are applied, so 18 changes. And now I updated the process a bit for changing the minimum requirements. So the first thing that you had to do for running that stuff, it is ubsync, as you can read here in that part of the manual. And then for installing everything, as I already said before, just copy that, change that space with that placeholder with the proper IP address, run it, and then because I don't have any parameter filtering by tags, all the playbooks will be installed. Okay. While it is downloading, let me explain what I changed with the requirements. For installing your EC2 console, there are 2 requirements that I didn't explain before. The first one, it is AWS command line interface. Here you have references for installing it from Windows, Mac, and Linux. And you also need you also need UV, which is the package manager of Python. So Python and UV, both of them will be requirements for running all the stuff that I have here. Instead of requiring Ansible directly, I prefer to require UV because here you have the references for installing it. Because thanks to that, only with ubsync, all the dependencies will be installed and everything is simplified instead of requiring Ansible, that sometimes it could be something that brings you, or that it has problems because of the version and etc. And then here it is the command that I used. But instead of running Ansible playbook directly, I ran the virtual environment for Ansible and later the virtual environment for Python, and then Ansible playbook itself. Of course, as I did before, if you want to filter with tags, just add tags at the end, and you will have the chance to apply. So not install all the playbooks that we have in the repos. For having or for taking a look on all the playbooks that match with those tags that you have here, you can look at the folder tags, and then, for instance, for taking a look about how Docker is deployed, here you have all the tasks with their modules, okay, associated for deploying it. The same thing happens for Micromamba, for Kitty terminal, and all that stuff. Okay. Here you notice how the deployment, the provisioning of applications is done in parallel. Okay. Now the task that it is being applied is install Google Chrome. I imagine this is done here, no? Not this install Google Chrome. This is the task. So using apt, we are installing this package for having Google Chrome ready to be used in that EC2 instance, and letting you browse from that instance instead of using your local computer. I hope this is not going to take long. if you pay attention on the list of the tags and how they apply filters, we can see, notice that, the visual Chromium browser, here it is where we are now. After that, it is JupyterLab UV, which is this one. And later we have Micromamba, which is this one. And this is the one that is being applied now. Here are just, we deploy 2 projects, as I already said, 2 JupyterLab projects. One, it is managed by UV, and the other one is managed by Micromamba. When everything is set up, I will show you how it is, how it could be used. Because when we finish that process, okay, the next thing that we have to do is access to that remote machine and then set up the Chrome remote desktop. Yeah, now it's done. Perfect. Here we already connected to that remote machine using SSH and the private key. And now, like you can read here, you have to use your local browser for connecting. Let me see where I have that. I think it is here. Let me open a browser. I will move that here for simplifying the explanation. You are at this point, and like you can read here, what you have to do with the browser is go to this URL. Okay, I go to this URL with my personal Gmail account. Then, as you can see here, you have to go to setup via SSH, which is this option that you have here. Then click on begin. Then, as you have here, next, so next, and then authorize. Then here, yes or yes, always you have to copy Debian Linux, which is the base of Ubuntu. Okay, I will use that. Then go back to the remote console that I have here, and I will paste what I copied in that web page. Here you have to set up your own PIN. 6 digits PIN is what I will use, yeah, because it is required, these 6 digits. Okay, this is a secret. Not share that with anyone. And then, okay, it is complaining because this file is not created, and now it says this is linked. Let me check in the end if this file is created or not, because it's crashed. Okay, and here we have, okay, it is the private key, so everything it is related with security. Of course, this machine will be destroyed after the video, so no worries about copying this secret information. Very well, after this point, as you can read here, the next thing that you have to do is sudo reboot. Take care, because it will reboot the remote machine. Not run that locally, because it will reboot your machine. It takes roughly 60 seconds until this machine is available again. What I will do is launch a ping when the machine starts booting, or the network interface of that remote machine is ready. I will see how the pings start returning to me. For a while, still the machine is booting. Because of that, pings are not returning. I am thinking that maybe those pings are not available because of the security constraints. Another thing that I could do, it is, yeah, check that. Is check if I have access to SSH, and I have access now. So the machine is ready. I use the same command like I did before for accessing remotely to the machine, and here we are. Then if everything is okay and you don't have to do anything else, what you have to do is click here in remote access. Notice this is disabled. What does it mean? It is this is not working like it has to be. So copy this, and then it says that it is active, by the way, it appears here as disabled. This is another machine, not the one that you are working with. So I will remove this one. It appears a new one. And this one, it is that instance that I see here. So good news. If I click here, the pin will be required. I put the same pin that I assigned before. And boom, here I am. Let me allow that. It is the remote desktop of that machine that we installed. And if I navigate to the applications, for instance, I can navigate to Google Chrome. And then it says if it will be set up with default. I don't want to sign in. And then here I say just I look it up for Linux, just as an example. And if it's okay, just to return the results of that. Yeah, perfect. It is. It's a bit slow because it was the first time that I look it up for something. Let me try another thing. Let me try looking up for Ubuntu, and you see now it is by far faster. Then I can go to the terminal emulator. Okay, here it is the Ubuntu home directory because we are the user Ubuntu, as you can see here. We have the chance to manage Docker, so instances for Docker. Docker run, whoops, let me change the configuration of my keyboard. And here, for instance, hello world. You can see how the image is downloaded and executed. It is the output of this image working perfectly. Very good. Then let me go to the JupyterLab samples that we have. Here we have, let me go this way. I think it is not the best way. Here we have JupyterLab, which is UV managed, and Micromamba. Let me start with JupyterLab. Here it is the project. UV will synchronize whatever package is needed for this project. And then I created this simple start SH, which will launch JupyterLab in this port. Okay, so no token is required, just for simplifying the process. And then with, sorry, it was a start. With this start, okay, you can see everything is running. I can go to this remote browser and say localhost. And here it is, okay, JupyterLab. If I go to the folder notebooks, it is the Hello World notebook that I created as an example. And then if I go here and I execute this cell, you have the output. Yes? So nothing special is required for running from this console. Then imagine that what you want to do is run that using Visual Studio Code. So you go to development, run Visual Studio Code. I will zoom in that to the maximum, just for showing you how it could be integrated with your environment. As you can see now, everything is maximized. Okay. Then if I open the folder, say JupyterLab, yes, I open it. And here you'll see the, as I trust it, you'll see notebooks. I open the notebook. Here you see the same notebook that I had outside. So if I click Control Enter, it says you haven't selected a kernel, so select this kernel. So something that you can do is because you have here, let me zoom out that. In the console, okay, we have launched a kernel. This is the kernel that we are using in that web interface that we have here. Yes? Let me see if I can change the size of the window. Better. We'll put that here. Okay. This interface uses the kernel that I launched from the command line. The best practice, it is not to use another kernel for Visual Studio Code. It is share the same kernel. Let me zoom in that a bit. No, it doesn't want to work. Let me see, appearance. No, where is the zoom here? I don't remember. So sorry. Sorry, I don't have zoom for that stuff. Oh yeah, no, better. So super zoom. Okay, then here, select kernel. Okay, select kernel, existing JupyterLab. Says where is that JupyterLab already running, and you say it is in local, or for instance 127.0.0.1.8888/lab. Give, yeah, connecting to the overall token, maybe, okay, yes, it is not very secure. By the way, it works. I say UV, just for giving a name, and referring that JupyterLab, it will be this way. Then, what it says, it is which kind of kernel I want to use. Select the default one. Now it's done. Then, if I come back here and I execute that manually, you can notice how the connection appears in the left side, because what it happens is this connects here and executes the cell and returns the output here. So, as you can see, this works. Let me repeat the same process, but now I will open a console here. And I have, this is the console number 1, and I open it, another console here, the console number 2. Okay. Then I go to Micromamba folder and I run start. So let me show you the folder first. It is another environment, very, very similar like the previous one, but the previous one was managed by UV, and this one is managed by Micromamba. In the README file that you have here, you have details for managing this environment and what are the commands that you have available. Okay, for instance, activate the Micromamba, install whatever. Yeah. Then here, start.sh. When Micromamba is running, it will be available, not import 888. Okay, import 889. Okay, here we have the Micromamba. Notice how this is moving because I am connecting from here. As you can notice, this is very close to the previous one, but here it says it is managed by Micromamba. Execute the cell and it works. Yeah. And then if I want to do the same here, just I will open the folder where I have Micromamba project. Say open. And then perfect. I open the notebook, which is here. It is the notebook. And then I will select the Micromamba kernel, so existing Jupyter server. Instead of port ended with 8, a port ended with 9 is where we have Micromamba, remember? Then I click enter here. Yes. And then here you say Micromamba kernel. This is just an arbitrary name, and we select the kernel that we want to use. Perfect. Then I will execute this cell, and boom, here it is. It runs. Maybe you have noticed how the console in the left was moved because for executing this cell, it is connected to the kernel, which is running in this console. It gives you the complete control about what's happening behind the scenes. Okay, then it is just a demonstration of all that stuff. Remember, what we have here, it is a remote machine. This is not the local machine. Maybe you have seen here appeared. I don't know why now it is here. Okay, this is the remote system, the remote service. Okay, it is running inside remote desktop. If you want, in Windows or in, I imagine also in Mac, but no experience on that with Mac, you have this application, which is an application that you can install in your Windows and then connect directly to the remote machine from here. You will notice how the browser in the back, in the backend will be disconnected once I log it in from here. Why do I recommend to use this application? Because this application is better, for instance, for sharing the clipboard between the remote machine and the local machine. Or for instance, you can click this button and it is completely integrated with the backend. And with this X that appears here, you can, let me say, disconnect or resize the remote system that you have. Okay. It is much more optimal. Usually, if your computer is not performing okay, the best it is just install this application, connect to the remote place, and use that remote site like if it was your local computer. It is very, very convenient, as you have noticed. Then other stuff that you can do with this system. Here I have the remote computer, the EC2 instance remote console that I was saying before. And here, what I will do, it is, here I have a local Chrome. This is my local Windows. Okay. And then what I do, here you have, maybe you already know that if you click here, you access to the commands. Then let me say remote, connect to host. Yes. Then go to configure SSH hosts. Then here it is where I have my config file in my Windows. And then you have to create, we say, an entry like this. Forget about the rest. Okay, those lines are not useful for you, but just focus on this one. Here, it is a path where I will copy the key that we generated during the deployment. Maybe you remember that we generated this key. Then what I will do, it is, I will copy this key to my Windows path. Here it is, EC2 key.pen. And then I will change that for EC2 key. And then I don't know what is the IP address of the EC2 instance that we created. I can see this is this one. If you don't want to get that using Linux console, another alternative, of course, is go to your instance, go to the EC2 instance, and then it is your instance. You select the instance, and here it is the public IP address. And as you notice, is exactly the same IP that I've got here. And you can replace that IP from here. Yeah. And then get that. Come back here and say, sorry, SSH. No, it is remote. Okay, remote SSH connect to host. Notice how I put this symbol at the beginning. What it means, it is, this is going to be a command. Bam. And then the commands appears automatically. It is EC2, SSM Ubuntu, blah, 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 all of them. By the way, what I want is this one. a new Visual Studio Code is opening, and as you can see here, it is connecting to that remote machine. Yeah, when it is connected, you will see that here. Okay, now you can say open folder, and here I have the remote folders that I have available. For instance, here I have the JupyterLab. I say okay, and then here it is, the remote project, but open from my local instance. If I want to use the kernel, I have to select one kernel, because in the end, I think the kernel that we set up in that Visual Studio Code is not the same one that I have here. Let me check if I click here what happened, because I don't remember. Then you can see kernel is still not selected. Maybe here we can see any debug. No debug. So not very useful. Anyway, I will try to execute this cell. Let me see what happened. Oh, no. This is what I expected. So, existing Jupyter server. Do you remember? It is exactly the same thing that we did before. Yeah? But now, what I will say it is, select a Jupyter server. No, I want to introduce a new one. Okay, because it is not the same thing that we did before. So I can say, for instance, remote. I was in, I want to use UV, no? Remote UV. Sorry, let me read that. No, it expects the URL. So if it expects the URL, I will put here, I copy the previous IP address. And if you want to use UV, then I say this URL, confirm, say yes, and remote UV as a name. I say this kernel is okay. And then pay attention when I had that. Let's see. It is the remote system. And then here we had UV. Let me put some spaces. Okay, I have here the cursor. When I'm executing this cell, remember, this is in local. This is in the remote EC2 instance. Execute that. Notice how it is running the content of my cell, and boom, here is the output. This is executed remotely. Then Control Enter, and boom. That connection still persists, and then it is executed remotely, not in the local kernel, in a kernel in the remote system. The same thing could be, we can do, we can repeat the same thing. Whoops, with Micromamba. Sorry, this is not the folder I want to do. This is the folder, Micromamba. Let me jump the place where I have Micromamba running. It is. Put some spaces, because when I'm connecting, I want to see the connection. I will open Hello World notebook here. Here it is. And then it tries to detect kernels. I say existing Jupyter one, and I will say enter a URL, HTTP, Then I copy this. Remember Micromamba in 8889/lab. Yes, and he said remote Micromamba. I select the default kernel, which is this one. And now, as you have seen, it is executed remotely. But I see that in my local VS Code. Okay. Why is that so convenient? Because maybe you don't want to set up in that remote machine the secret keys that you use for managing LLMs, no, agentic coding and all that stuff. Then an option is have your Visual Studio Code locally with your private keys, and then not execute that in remote. By the way, this computer that you have in remote is completely functional. Okay. If you want to install anything that it is not provided, of course you can do it. For instance, let me open here and say install Cloud Code. You have a quick start for installing this. This is the command for Linux. Just copy it. I go to the console, and then I open a new session here, the session number 3. And now I copy the command for installing Cloud Code. Then, as you have seen, it is in the process. It is installing Cloud Code. Of course, I could provision that from scratch, but it is, in this case, just an example for showing you how it is installed. And here it is the process of setting up or configuring your own Cloud Code. Not much more for this video. I don't want to enlarge it much more because it's quite long. I hope it was enough for letting you understand why this EC2 Console project, it could be useful if you have issues with your Docker in your Mac, if you have issues in your Windows laptop computer, which is not powerful enough for running some kernels or some stuff. Here it is a solution which is very, very convenient. And don't forget, this is a cloud. What does it mean? It is you can go to the console and stop that instance, start that instance manually, or maybe in future, what you want to do, it is scale up or scale down the power of this EC2 instance for running much more sophisticated stuff, for instance, for training models, or for just not paying so much when you are developing something easy to do that it doesn't require so much computing power. Okay, I don't want to enlarge much more this video. I hope it is useful for you.